Good morning. Today we're going to do 1-2 basic probability. Probability is the number of favorable outcomes divided by the number of possible outcomes. The probability of an event occurring is always between 0 and 1. Inclusively. So what that means is it could be 0 and it could be 1. When we usually look at probability, the closer the probability of an event is to 1, the more likely it is to occur. If you have a probability of 1, you are saying it is 100% for sure going to happen. And the closer the probability of an event is to 0, the less likely the event is to occur. So if you have a probability of 0, that means that event, no matter what, can never ever happen. Probability can be represented using a tree diagram, or using combinations. And we will use combinations when we are selecting more than one. Remember, combinations is your NCR. So combination is when selecting more than one. And what this means is, say you're selecting cards out of a deck, you pull 2 cards. Probability is stated in as a number in 3 forms. We're going to have a fraction. We can then write that fraction as a decimal. And finally, we can write it as a percent. And this is how we are going to write it each time. Okay, so percent is the one that occurs the most often, and actually what we'll be using for the remainder of this assignment. We'll be doing everything as percents. So let's take a look at example 1. So it says determine the probability using a tree diagram in its 3 forms. That means I want it written as a fraction, a decimal, and a percent. So when 2 coins are tossed, what is the probability there will be at least 1 tail? So when I draw my tree diagram, we have my first coin. And with your first coin, you can either get a head or a tail. And then I have my second coin. And that coin can either be a head or a tail. And from here, we write our possible outcomes. And this is just like we did yesterday. We follow the tree diagram down. So my possible outcomes is head, 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 tail, tail, then a head, and tail, tail. So what I want what this question is asking is what is the probability of at least a tail. So when we write it out, we always write what are we finding the probability of. So the probability of at least one tail. So let's look, when does that happen? Here it has one tail, here it has one tail, here it has two, but that is bigger than at least one. So the probability is 3 out of 4, which is 0.75. And to turn a decimal into a percent, remember we multiply by 100. So it's 75%. Let's take a look at B. A woman wants 3 children. What is the probability that she will have 2 boys? So I have a first child. So we can have a girl or a boy. And now I'm going to have a second child. And that child can be a girl or a boy. And finally, I have a third child. And that can be a girl or a boy. And past this, I'm not going to ask you to do tree diagrams past like 3 rows or 4 rows. It just gets very confusing and hard to read. So let's list our possible outcomes. So I can have girl, girl, girl. I can have girl, girl, boy. I can have girl, boy, girl. And I can have girl, boy, boy. I go over to the next one. I can have boy, girl, girl. Boy, girl, boy. Boy, boy, girl. Boy, boy, boy. And what it says is, what is the probability that she will have 2 boys? This is an exactly problem. So I want she wants 2 boys, that means 1 girl. So the probability of 2 boys. Here's a 2 boy. Here's 2 boys. Here's 2 boys. This last one doesn't work because it's 3 boys. She wants 2 boys exactly. So that is 3 out of 8. And if you divide by 3 into 8, you get, wait a minute. Sorry, I read that wrong. It doesn't say exactly 2 boys. So this boy, boy, boy will work. She just says 2 boys. So 3 boys does have 2 boys within it, so that does work. So that's 4 out of 8, which is 0.5, which is 50%. Okay, let's look at example 2. So for example 2, our directions say express the probability using combinations as a percent. So everything is just going to be a percent. Ebony has 4 male kittens and 7 female kittens. She picks up 2 kittens to give to a friend. Find the probability the following. So she just picks up 2 at random. 4 plus 7 gives me 11 kittens total. So the probability of getting 2 males. So if I use combinations, how many males do I have to choose from? I have 4. I'm choosing 2 divided by 11 total kittens, choose 2. So we put this in our calculator, you get 6 over 55, and then divide it out, multiply by 100, you'll get 10.9%. For part 2 of this one, I want 2 female cats. So the female cats, she has 7 to choose from. So it's 7 choose 2 all over 11 choose 2. So that gets me 21 over 55, which is 38.2%. 3 is 1 of each. So that means I want to choose from 4 of the male kittens. I want to choose 1. And, so we're going times, I want to choose 1 of the 7 female cats. But on the bottom, I'm still going to do 11 choose 2 because I'm picking just 2 cats. So you get 4 times 7 are the 2 numbers you get, which is 28 out of 55, which is 50.9%. And finally, 1 male, 2 females. Well, this is 3 kittens total. She only said she was picking up 2 of them. So can 3 kittens ever happen? No. So you can't get 1 male and 2 females, so this has a 0% chance. She only picked up 2 kittens. Coming over to the next one, Bob is moving and all of his CDs are mixed up in a box. 12 CDs are rock, 8 are jazz, and 5 are classical. So that he has 25 CDs altogether. He reaches into a box and selects them at random. So it didn't say how many he selected. So that isn't going to play into account like the kittens did when she picked up 3 kittens and she said she only picked up 2. So it doesn't say he's only picking so many. So any number is fine. So the probability of 1 classical, when I use just picking 1, it's a simple probability, which means I just divide. So he has 5 classical CDs out of 25. So we plug that in our calculator and we get 20%. We don't have to use combinations when we are just picking 1. So here we're picking 3, that is more than 1, therefore we do have to use combinations. So I'm picking 3 jazz, there were 8 total, so it's 8 choose 3 over 25 choose 3. So we get 56 over 2300, which is 2.4%. Remember, we divide out, multiply by 100, that'll give you your percentage. 2 classical and 1 rock. So let's start with the 2 classical. So I am choosing from 5 classical CDs, 2 of them. Now, since I use combinations on the first one, I'm going to use combinations on the second. So you can do it choosing one, but you don't have to. So if I choose one rock, he had 12 to choose from, and I'm choosing one. And on the bottom, it's 25, choose 3, because he chose 2 of classical, 1 of rock. That's 3 CDs altogether. I get 120 over 2,300, which is 5.2%. Okay, if I go here, 2 jazz, 3 reggae. Well, if I look back up at the top, he didn't have any reggae CDs. So can he choose 3 of them? No. So he has no reggae CDs. Therefore, this probability is 0. And finally, 1 classic, 1 jazz, 2 rock. So it's 5 choose 1 times 8 choose 1 times 12 choose 2. And this time there's 4 CDs, so it's 25 choose 4. So on top, when I get my numbers and I multiply them out, I get 2640 all over 12,650. So that is 20.9%. So let's go and try to use a table to get some of this information as well. So let's look at example 3. So if I look at example 3, it says, use the table that shows the college majors of students who took the medical college admission test, the MCAT, in April 2000. If a student taking the test were randomly selected, find each probability. Express your answer rounded as a percent. So what is the probability that they majored in math or statistics? So I come over here and I look for the one that said math or statistics. So that is 179 out of my total that took it, which was that's other. The total. So we have to find that by adding those up. And your total is 25,405. So when you divide that out, you get a very small number, multiply by 100, and it's 0.7%. So it's less than a 1% chance that the person that took the MCAT studied math or science. Biological sciences, this is where the majority of them are. So that is the top row, so that is 15,819, divided again by the total, which is 62.3%. And finally, social sciences or humanities. So I find social sciences and I find humanities, and I am going to add those totals together. So it's going to be 22,482 plus 963. Again, all over the total. And when I add those up, I get 3,445. And divide them out, I get 13.6%. So this part is just being able to read the total or read the table, find the total, and figure out what you need to know. The last thing we need to talk about is geometric probability. So let's take a look at that next. Geometric probability is, so here's our way of finding it, area of desired outcome, whether that's shaded, not shaded, however they describe it, but what am I looking for, over the area of the total outcome. So since this is geometric, we need to remember some of our area formulas. So area of a square is side squared. Area of a rectangle is length times width. Area of a triangle is 1/2 base times height. That's a height. And area of a circle is pi r squared. So if I look, it says find the geometric probability for each given situation expressed as a percent. So a coin is thrown from a ladder. Find the probability that the coin landed in the shaded region. So the shaded region is my desired outcome. The whole region or the whole rectangle is my total outcome. So what I'm looking at for this problem is I will do area of triangle divided by area of the rectangle. And before I even start in on these problems, I come up with a game plan. You need to write down what it is you're finding and then go ahead and find it. Okay, I do not want you just skipping right to numbers. This right here is a must. You must write down your game plan. What are you doing? What's on top? What's on bottom? Okay. So here the area of the triangle, remember that's 1/2 base times height. So 1/2 times my base. Well, I don't know my base right here. But I do know that this and this are the same length and the whole thing's 14. So this must be 7. So it's 7 and my height is 10. All divided by area of the rectangle. So that is length times width. So it's 10 times 14. So I multiply the top, I get an answer. So it's 35. Bottom is 140. Divided out, I get 25%. So I have a 25% chance of throwing a coin from a ladder and getting into that triangle. If I look at B, a rock is thrown from a second-story building. Find the probability that it lands in the shaded region. Again, the shaded region, but now there's 4 of them. And those are some weird shapes. I don't have a way of finding that area. So we got to think about a different plan. So I could find the area of the square, and I can find the area of the circle. So the shaded region is all that's outside of the circle, but still inside the square. So my game plan is going to be area of the square minus area of the circle, because that will get me my shaded region, and my total region is again the square. It's the bigger shape. So on top, area of the square, that's just 16 squared, minus, if I do the area of the circle, So to do area, I need to know the radius. So from the center out, the whole distance is 16, therefore this is 8. So that's going to be pi 8 squared. And on bottom, again, that's area of the square, that's just 16 squared. I'll put the entire top in my calculator using the pi button, and I'm going to save it in my calculator because I'm going to just write a few numbers, but I'm going to, again, use the answer feature to be able to use that. And then 16 squared is 256. So I take this top answer divided by the bottom, and I get 21.5%. Okay, let's take a look at the last two. It says a dart is thrown at the dartboard below. Find the probability that the dart landed in the shaded region. Well, I have two shaded regions here. I have a triangle and a rectangle, a small rectangle. So my plan is going to be that I add those two areas together. So area of small rectangle plus area of triangle, because I can find both of those. I have formulas for that. All divided by the area of the bigger rectangle. And I'm just going to make it bigger so I know. So if I start with here, area of this small rectangle, that's this right here. So we're all looking at the same thing. That's 4 by 8. So that's just 4 times 8. Plus. Now I need to do area, of this triangle. Well, to do area, I have to do base, 1/2 base times height. So I have the 1/2, my base is 8, but I don't know the height. So I need to figure this out. And to do that, I'm going to use Pythagorean theorem, because I've just made a right triangle. So this distance is 4. So it's going to be 4 squared plus 8 squared, h squared, equals 8 squared. Because these little markings mean all these three sides are the same. It's an equilateral triangle. So we get 16 plus h squared equals 64. So h squared is 48. So that means h is the square root of 48. And I'm going to leave it like that. I'm not going to find a decimal for it because there's no point, because I'm going to plug it into a formula. And this is all divided by the area of the large rectangle. So this right here. And that is 18 by 8. So again, I put the top in my calculator, I put the bottom in my calculator, I save those numbers so I can come back to them. So it's 59.713 divided by 144. And you get 41.5%. Now you could go ahead and type all of this in your calculator using the fraction bar if you want, but you have to be careful to make sure you don't miss some parentheses or that sort of thing. So if you're worried about that, do top and bottom separately and then divide them out. Finally, an archery target has 5 scoring zones formed by concentric circles. That just means they're all centered around the same point. The radius of the yellow zone is 12.2 centimeters. So here to here is 12.2. The width of each ring is also 12.2. So each ring grows by 12.2. didn't finish my line. The width. So when I do this one, so here's another 12.2, 12.2, 12.2. Okay? And how many of those 12.2s did I have? Sorry, I misspoke when I said I didn't finish the line. It did say radius, so that is 12.2. So I have 5 of those. 1, 2, 3, 4, 5. So to get this long line all the way to the outside, it is 12.2 times 5. So this distance right here is 61. It says, what is the probability that it hits in any area of the red zone? So if I just want the red, I don't want the yellow, I am going to have to find both of them. So it's going to be area of red minus the area of yellow divided by area of the total circle. So the red area, let me pick a good color. So the radius of that circle is 12.2 plus another 12.2, so that is 24.2. So it's going to be 24.2 squared times pi, because it's pi r squared. Then if I look at the radius of the yellow one, so that is going to be minus, the radius of the yellow one is 12.4, sorry. $24.4 minus 12.2 squared times pi. And that's all divided by the area of the entire one, which is 61 squared pi. Notice all of these have a pi in them. So when I multiply, I'm not going to multiply by pi. I'm going to leave it as a variable. So I'm going to do 24.4 squared minus 12.2 squared. And then I'm going to do 61 squared. When I do that, I get 446.52 pi. And 61 squared is 3,721 pi. Now my pi's cancel out, so I just divide the numbers, and my final answer is 12%. Go ahead and go work on the assignment. If you have any questions, feel free to ask me tomorrow. Thank you.